array. But in case we need it, we don't need to then calculate it separately. We can simply take the result of this function here, store it into a variable, and then use that. Great. Now, besides the push method, which adds elements to the end of the array, there's also a method to add elements to the beginning of the array. So that is the unshift method. So unshift. And so let's say we wanted to add John right to the beginning of this friends array. So again, let's check it out. And so now it should have 5 elements, and the first one should be John. And yeah, it is. And just like the push method, the unshift method also returns the length of the new array. But in this case, we are just not saving it because we don't really need it. Next up, we also have methods to remove elements from arrays. So these one here, add elements. So let me just write that here. Add elements. And then we have some to remove elements. And let's start with the pop method, which is basically the opposite of the push method. So this means that pop will remove the last element of the array. So let's write that here. And this time we don't need to pass in any argument. And that's because there's no information needed really to just take out the last element. So let's try that. Oh, we didn't log it again to the console. So let's just grab it from here. And now you see that J is actually gone. And if we did it twice, for example, which of course we can also do, then Peter should also be gone. And indeed, we removed J and Peter. Now again, this pop method also returns something, but this one doesn't return the length of the new array, but instead it returns the removed element. And so that can sometimes be useful. So let's call this one popped, okay? And so let's log that one to the console as well. So that is the popped element. And we could do the same for this first call. But as I said earlier, we don't always do this because it's not always that useful. But here I just want to show you that it actually works. And so the popped element should now be Peter. So this first one here is J, and then the last one becomes Peter. And so here in the second pop call, Peter is the one that's being removed. And so that's the element that's then going to be saved into popped. And yeah, here it is. Okay. And finally, let's also remove the first element from the array. And so that's friends that unshift. So let's copy this one again. Give it a save. And so now only Michael and Stephen should be left after all this manipulation, right? Oh, and actually that did not work. And that's because I did a mistake. So unshift is of course to add elements to the array. And so this one here is called shift and not unshift. So now it should work. Yeah. Once again, we didn't need any arguments. And once again, this method here will return the element that was removed. So if we need that, we can capture it. Next up, there is a very useful method that tells us in which position a certain element is in the array. So let's work with this small array that we have left. And what we want to log to the console now is friends.indexOf. And then we pass the element which we want to reference. So let's say we want Stephen. And so, as I said, this should return the index at which this element is located. So we know that Stephen is right now element number 1, right? So 0 and 1. And we actually can see that here in the console. So 0 is Michael, 1 is Stephen. And so this indexOf function call should return the value 1. Because again, that's the index of the element Stephen. And yeah, there we go. Now, if we try the same thing for an element that is not in there, let's say Bob, we will get -1. All right. And now finally, to finish this, this lecture, there is a very similar method to the indexOf, but which is a bit more modern and, in my opinion, also more useful. So this one is an ES6 method, and it's called includes. So includes, instead of returning the index of the element, will simply return true if the element is in the array and false if it's not. So let's check that. So friends.includes, and now we can actually do the same as up here. So let me just copy that. And the difference here is, again, the includes method. So let's see what we get now. And as expected with Stephen, it is true, because indeed we have one element here, Stephen, but Bob is false, because, well, there is no element called Bob. And this method actually uses strict equality for this check. So let's say that we pushed some value here to this array. So friends.push, which, remember, will add a value to the end of the array. So if we added 23, and then if we checked for 23 the string, it would not work. So it would say false, right? And that's because it is testing with strict equality, which means that it does not do type coercion. And since 23 the string is different from 23 the number, it gives us false. But if I test it directly for the number, then it should be true. And yes, it is. So we added it here to the array, and so then, of course, the array includes it. That makes sense. And so we can use the includes method to write conditionals. So that's one of the very useful applications of this method. For example, just to test it out very quickly, let's say friends.includes Peter. And then, if so, we can log to the console, you have a friend called Peter. Okay? So we already know that this here returns a Boolean, and we also already know how the if statement works. And so only if this is true, so if the array does include a string with Peter, only then this code is executed. And so right now, of course, nothing happens. But if I ask for Stephen, then here let's say Stephen as well, then I get, you have a friend called Stephen. So that's probably the most used case of the includes method. All right, and that's all I had to show you for this lecture. And as I said in the beginning, there are many more useful methods for manipulating arrays. But for now, I just wanted to show you the most basic ones. And next up, there's yet another coding challenge waiting for you. All right, here goes coding challenge number 2, which is going to be all about arrays. And in this one, we're going to go back to the tip calculator that we built in the previous section. And we're still using the same rules as before. So we tip 15% of the bill value if it's between 50 and 300, and if the value is different, so outside of this range, the tip is 20%. And so here are your tasks. First, write a function called callTip, which takes any bill value as an input and returns the corresponding tip. And so that's going to be based on the rules that I just mentioned. And to do this, you can actually check out the code from the first tip calculator challenge that we did in the last section. So you can copy the code there, or if you want, you can also code this from scratch just to remember how to do it. And now in number 2, we're finally going to use arrays. So here we're going to create an array called builds, which will contain the test data that we have down here. So these are the 3 bill values for which we want to calculate the tips. And so that's what we do in point number 3. So here we create an array called tips, which will contain the tip value for each of the 3 builds. And this is where we're going to use the calc tip function that we created before. So that's the basic challenge. And if you want to take it one step further, you can even take the bonus question, so number 4 here, in which I ask you to create an array called total, which will have the total values. So that's the bill plus the tip. So I hope this one isn't too hard. Basically, it's similar to one of the examples actually that we did in one of the lectures about the arrays. And once again, I also have a hint to help you solving this one. But if you want to try it on your own without the hint, then pause the video now and good luck. But if you want a hint, well, then here it goes. So remember that an array needs a value in each position, but that value can actually be the returned value of a function. So as an array value, you can basically just call a function. All right. And again, that is similar to something that we did in one of the array lectures. So pause the video now, and I see you with my solution in a second. Okay, and I'm going to start by creating the calc tip function. And I'm going to start doing it with a function expression. So this one will receive a bill as an input, I think, yeah. So calc tip takes any bill as an input. So let's simply call it bill. And then what we want to return is the tip. And here I'm going to write the exact same code as we did in the other challenge. So there's no need to explain it all again. It would just be a waste of time. So if the bill value is between 50 and 300, so less or equal than 300, and here we're using the ternary operator, then return the bill value times 0.15, so that's 15%, and otherwise it should be 20%. Okay, so the result of this ternary operator here will be one of these values. So either bill times 0.15 or times 0.2. And so that's going to be the result of this operator. And so that's what this function will return. If you prefer the arrow function, we can also do that. So const calc tip equal bill. And now we can omit the return keyword and do it all in one nice line. So now you just have to choose which one you like better. And I will just, for the sake of readability, keep the first one there. Okay? But if you prefer the arrow function, you can just use this one. Great. So number 2 is to simply create a builds array with these 3 values. So builds 125, 555, and 44. So that was easy. And now we will create an array tips, which will contain the tip value for each bill. So let's do that. And now this is similar to what we did previously with calculating the ages. So we are going to create an array, and then each position will be the function call to calc tip. So we want to calc the tip with builds at position 0. Then at position 1, we want to calculate builds, or we actually want to calculate tips based on builds on position 1 and then on position 2. And that's it. So let's log both the bills and the tips to the console here. And that gives us tips is not defined. So here it should be tips. So usually when I have an array, I like to give it a plural name, like here bills and here tips. So because it's multiple values. So now that should work. And yeah, so these were the 3 tips that were calculated. And of course, you could have created separate values or actually separate variables for each of these function calls, like tip 1 equals calc tip with bills 0, something like this, and then tip 2 and tip 3, and then you could have created like an array with tip 1, tip 2, and tip 3. Okay, so something like this. But my idea was to actually do it like this, because then we don't have to create all these extra variables. So that's a lot cleaner. Later on in the section, we will find an even better way of doing this. But with what we know at this point, this is the best that we can do. So we take the first bill, calculate the tip based on that, and put it in position number 0. Then we take bills at position number 1, calculate the tip, and put it in position 1 of this new array. And then we take bills at position number 2, calculate the tip, and put it at position 2 of the new array. And so then, yeah, we end up with this. Lastly, let's also complete the bonus question number 4 here. And all we have to do here is to create an array which will have the sum of the bills and the tips. So that's going to be totals. And now you might have tried to do something like this. So like bills plus tips. But as I told you in the previous lecture, this is simply not going to work. So we cannot do any operations on arrays like this. It doesn't work like that. So let me show you the result that we would get from doing this. And so basically, each of the arrays would be transformed to a string, and then the 2 strings would be concatenated. So that's completely useless. And so the only thing that we could do is to say that we want bills at position 0 plus the tips at position 0. And now we do this for all the 3 values. So at position 1 as well, and then at position 2. And so this fixes this error, because now in each position we do actually have a real value, because this is an actual value, and so with that we can then do calculations. So yeah, this is correct, looks correct, right? And yeah, so with that, all of the 4 points are solved. And so here we conclude this part about arrays. So after arrays, it's now time to learn about another data structure in JavaScript, which is objects. So up until this point, we have been using arrays as a data structure to basically store multiple related values in the same variable. So let's just quickly recap that. So Jonas array, and you don't need to write this code. Okay, I'm really just trying to recap here. So we had the first name, and you see that I'm writing this in multiple lines now, and that is perfectly acceptable. So sometimes that's easier to give us an overview of a data structure. As long as we remember the commas here after each of the elements, we're going to be fine. So then we have kind of this age calculation here. Then we had the job and even an array of friends. So we have an array inside an array. So Michael, Peter, and Stephen. So again, this is basically a data structure which combines multiple values which all belong to this Jonas entity. Now we know intuitively that this first element here of the array should be called the first name. And this one is the last name. This one could be called age. This one could be called job. And this one could be called the friends. But in arrays, there's no way of giving these elements a name. And so we can't reference them by a name, but only by their order number in which they appear in the array. And so to solve that problem, we have another data structure in JavaScript, which is objects. So in objects, we actually define key value pairs. And so then we can give each of these values here a name. So let's see how. So again, we're defining a variable. And so I'm calling this one Jonas now. And then this is the actual object. So now instead of the square brackets that we use for arrays, we use the curly brackets or curly braces. So this is the second time we're seeing the curly braces. First, we saw them to define a code block, for example, in an if-else statement or if a switch statement, or even to define a function body. But this is different. Okay, so these curly braces here are to define a new object. And so let's now fill up this object with key value pairs. So the key is basically the variable name. So let's say first name, then a colon, and then the value. And the value can be of any type that we want here. Then to define another key value pair, we just separate them with commas, just like in the array. So last name, and then colon, remember, Schmettmann, then the age, and once more, we can put any expression here. So this will be calculated and then will be assigned to age. Then the job, which is teacher, and finally the friends. And let's just copy this array from here. Okay, and so with this, we have now an object which contains 5 key value pairs. So again, these are the 5 keys, and then each key has a value. And so essentially with this, we were able to assign a name to each of these values that we had. So that's something that was impossible in arrays, but now it is possible. Now each of these keys is also called a property. So we say that this object here, so this object, which is called Jonas, has 5 properties. So property first name with the value of Jonas, property last name with the value of Schmettmann, and so on and so forth. Now, objects are probably the most fundamental concept in the whole JavaScript language. So there are many ways of creating objects. And simply writing an object in the code like this is probably the simplest way of creating an object. So here with the curly braces. So there are multiple ways of creating objects, but again, using the curly braces like this is the easiest one, and it's called the object literal syntax, because we are literally writing down the entire object content. So to recap, just like arrays, we use objects to essentially group together different variables that really belong together, such as the properties of Jonas that we've been working with. Now, the big difference between objects and arrays is that in objects, the order of these values does not matter at all when we want to retrieve them. And that's important to keep in mind. So in arrays, the order in which we specify the elements matters a lot, because that's how we access these elements, right? So we can only access array elements using their order number. This means that we should use arrays for more ordered data and objects for more unstructured data, and data that we actually want to name and then retrieve from the object based on that name. But how do we actually do that? So how do we get data from an object? And that's exactly what the next lecture is about. So see you there in a second. In this video, you're gonna learn how to retrieve data from objects and also how to change data in objects using both the dot and the bracket notation. So let's actually get the object here from the previous lecture. So that's Jonas object. And I noticed that we actually didn't even take a look at it in the console. So let's quickly log it. But we're actually not gonna see a big surprise. So all it shows us is really this same object that we just wrote in code. So it looks like this. So essentially just as it is here in the code. The only thing that's different is that the properties here are ordered alphabetically. And so that's what I mean when I said in the last lecture that the order of properties does not matter. And that's because we simply get the properties from the object using the property name itself. So that's actually the topic of this video. And so let me show you the two ways in which we do that. So the first way of getting a property from an object is by using the dot notation. And that is very straightforward. So let's log that to console. And so let's say that we want to get the last name. So all we have to do is to write Jonas dot last name. And that's it. You see, here is my last name coming straight from the Jonas object. So Jonas dot last name. And this dot here is actually an operator which will go to this object and then retrieve the property with the name that we specified here. Now we can do the exact same thing using the brackets notation. So let me show that as well. So Jonas, and then we use brackets in a similar way in which we retrieve data from an array. But here we need to specify a string with the property name. So with the key. So let's do my name again, or actually last name. And so these results should be exactly the same here. Now the big difference between these two here is that in the bracket notation, here we can actually put any expression that we'd like. So we don't have to explicitly write the string here, but instead we can compute it from some operation. Because remember that an operation is basically an expression. So something that produces a value. And so we can put that here inside the brackets. So let's actually try that. And imagine that we had a variable in which we store the repeating part in first name and last name. So we have name here in both. And so let's store just that inside of a variable. And you will see my point here in a second. This will all make sense, trust me. So name key, and then just name. So again, that's the repeating part in these two property names. And now we can use that variable to get both the first and the last name. So console.log, and then Jonas, brackets. And so now here we can insert the expression. So let's create a string first and concatenate it with name key. And here we could have built this string using a template literal, but in this case, it's not really necessary. So let's just copy this and then also last. So what will happen here is that as JavaScript sees this line of code, it will start by executing this plus operation, and so it will create the string first name. And then it will go to the Jonas object and retrieve that property. And the same for the last name here in the second line of code. And so that's how we get Jonas and Schmettmann. And doing something like this is more common than you might think. And so that's why it's important that we understand that in the square brackets, we could put any expression here. Okay? Now the same thing would not work with the dot operator or the dot notation. So we cannot write Jonas dot and then this here, for example. This would not work at all. So an unexpected string. And so that's the reason why we need the brackets notation. In dot notation, we have to use the real final property name and not a computed property name. So, for example, this one. This one is a real property name as it appears in the object. And so that's why it works here in this case. So, in what situations should we use the dot notation, and when do we have to use the brackets notation? And I kind of already replied to that, but this is just to recap. So when we need to first compute the property name like we did here with the first and last name, then of course we have to use the bracket notation. In any other case, just use the dot notation, which looks a lot cleaner and is also easier to use. Okay? And now to make the need for the bracket notation even more clear, let me show you another example, which I think is going to be really fun. So let's say that we don't know yet which property we want to show. And instead we get this information from some user interface. So for that we can use the prompt function, remember? So we can use prompt, and prompt is yet another built-in function that is built into JavaScript and that we can use in any script. So here we can write a string, and then this will create a pop-up window with an input field, remember? So here we can write, what do you want to know about Jonas? Choose between first name, last name, age, job, and friends. And remember that this function will then return a string, and this string we just need to store into some variable. So let's call this one interested in. All right. And to start, let's just log this interested in value to the console here, just so we see that it actually works. And so here is the pop-up. And so now we just write one of these options here. So let's say job. And indeed, now here we get job. And so what we want to do now is to basically display the job here in the console, because that's what the user chose. So how will we do that? Can we use the dot notation? So basically, can we do this, Jonas.interested_in? Well, let's find out. But I hope that you can guess. And so we get undefined. And this is something new that I didn't explain yet. And so let me tell you now that undefined is what we get when we try to access a property on an object that does not exist. So Jonas does not have a property called interested in, right? And so therefore, the result of trying to access interested in on Jonas is undefined. Now, what we need to do here is, instead of the dot notation, use the brackets notation, because then we can put any expression here, which in this case will be interested in. And so JavaScript will now come here and replace interested in with the actual value of the variable, and then that's the one that will be looked up on the Jonas object. So let's try that again. And now, when I say job, we get the correct result. Great. And I hope that you did understand the big difference between using the dot notation and the bracket notation, and why the bracket notation gave us the correct result. So again, it's because basically this expression that we put here between these brackets will get evaluated. And then this one here is job. Now, of course, we can also pass in something else. So something that is not here. For example, let's try to access the location. And then again, we get undefined. And once more, that is because there is not a property called location on the object. So let's actually handle that using some knowledge that we already have. So we know that undefined is a falsy value, right? And so we can use that to our advantage now and create some logic that will print a custom string whenever the user tries to access a property that doesn't exist. So let's do that. And we can say, if Jonas brackets interested in, then log that to the console. So basically this. And again, I'm using now the option and arrow down to move this line. And so if this value exists, then it is a truthy value because it is not undefined. And so any string that is not empty or any number that is not 0 will then trigger this code block here to be executed. Now, if one of these properties was actually empty or 0, we would then go to the else block, but let's not account for that here in this case. Let's say that doesn't happen. All right. So in case that the value does not exist, so for example with location, we then get undefined. And so in this case, Jonas interested in is undefined, which is false. And therefore we would go to the else block. And so let's say something like wrong request. And then we can repeat this sentence here. So let's try that again here. So location, and now we get wrong request. But if we try something that exists, then we get that result. Great. So I think this was a fun little experiment here. And yeah, I hope you liked that. And now that you know how to retrieve elements from an object, let's also learn how to use both the dot and the brackets notation to add new properties to the object. So that's pretty straightforward. So all we have to do is Jonas dot, and now let's actually use location and set it equal to something. So to some value. So I'm located in Portugal. And so that's how we use the dot notation. And then we can also, of course, use the brackets notation just the same. So let's say my Twitter handle here, which is @Jonas Schmettmann with just one N. And you should definitely check that out. And now just to see that it worked, let's log it to the console one final time. And okay, it's asking us for the field name again. But anyway, now we have the location and the Twitter here as well in the object. And of course, here we could put any expression just like before. So it works in the exact same way. All right. And that's how we use the brackets and the dot notation. Now, finally, I have one small challenge for you that you can just do right now here at the end of this video. And so what I want you to do is to write a sentence like this one that I'm going to show you now, but in a dynamic way. So let's just write challenge here. And so I want you to write, Jonas has 3 friends and his best friend is called Michael. So here we suppose that the first friend in the array, so in the friends array, is the best friend. Okay, and for the record, I do have more than 3 friends, but of course here we need to keep it all very simple. So again, I want you to write this sentence, but without hard coding any of these values. So what you need to get from the object is this value, and this value. And this is actually a bit hard, I would say. And so there's absolutely no need for you to nail this. But you can still try it, and maybe you can do some of the parts. One hint that I can give you is that you will need to use multiple dots to get the number of friends. Okay, so that's totally possible. And so take like 5 minutes to try this out now. So pause the video and I'll see you in a second. All right. And so this is how we would do this. So we want to log this to the console, of course. And so we're starting with the name. And this one is probably the most straightforward one. So that's just Jonas.first name. So that is where the name is stored. Then has, and then the number of friends. So the friends are stored in Jonas.friends. Now, do you remember how to get the number of elements in an array? It is by writing the array dot length, right? And so let's do that. So Jonas dot friends, and so this is our array, right? And so on this array, we can now ask for the length. And so basically you can see here that length is also a property that is available on all arrays. So it's a property that we don't define ourselves, but it's automatically available. But now that you know about the dot notation, you can also start to understand that the dot length is just a property that is available on all arrays. And so that's what we're doing here. So again, we have an array, which is this one. And on there, we can simply then request dot length. Okay, let's continue the sentence now. And his best friend is called, and now we need to simply get the first element from the array. And so that's again Jonas.friends. And now remember, we get the first element of an array using square brackets 0. And that's it. So once more, this here is simply an array. And so we learned that to take the first element, we just use square brackets with 0. So in a sense, on arrays, we also have the brackets notation. Okay, so let's just test this. And again, this annoying pop-up. But indeed, Jonas has 3, and we're just missing the friends here. So friends, and his best friend is called Michael. So just what I had written here as a template. Now in terms of operator precedence, let's quickly check out why it actually works this way. So with the dots here. Because remember, as I said, the dot operator here is really just that. It's just an operator. And the same goes for the brackets. So I will again Google MDN operator precedence. But the link to this table is also on the resources pages on my website. And the link to that one is right in the first text lecture of the course. But anyway, here we have the dot notation, which here is called member access. And then we have the brackets notation, which is here called computed member access. And so the computed is because, as I mentioned multiple times now, because we can compute the property names that we want to access. Now what matters here is that they both have a really high priority and both are left to right. And so that's why all of this works. So we have 2 dots here. So Jonas.friends.length, and they are executed left to right. And therefore, the first thing that JavaScript does is Jonas.friends. And so essentially, this will then be replaced with the array. And then on that array is where the dot length is then applied. And the same thing here. So first, Jonas.friends is done. And then this one is also left to right. And so from there, we take element number 0. Okay, so there's no magic involved here. There is rules for everything, and everything makes sense. And again, you don't need to memorize this here. With time, all of this will become second nature to you. Let's keep exploring objects. And this lecture will bring us to object methods. So we learned that objects, just like arrays, can hold different types of data. And they can hold even arrays, and in fact, they could even hold objects inside objects. But now we can take it even further. And for that, remember how I said that functions are really just another type of value. And if a function is just a value, then that means that we can create a key value pair in which the value is a function. And that then means that we can in fact add functions to objects. And so let's now see how. And once more, I will get back this object here, but we will change it up a little bit this time around. So here, let's simplify and just put the birth year. So just 1991. And I also want to add a Boolean here. Has driver's license. Just to show you that we can hold all kinds of different data types in one object. But now let's also add a function here as a key value pair. So to do that, all we have to do is to add another key here. And the function that we want to add is again the calc_age function. So that's one of the favorites, as you can see, but it is because it's a very simple calculation that we can do with the birth year. So to do that, let's simply add the name basically of the function here as a key. So as a property, so calc_age, and then the colon. And now here we simply specify the function as an expression. And that works because the expression produces the value. And so we can just do this. So function, and just like before, we pass in the birth year, and we return 2037 minus the birth year that was passed in. So this is pretty similar to simply writing this, right? So a regular function expression. So const calc_age like this. This is how we used to do it before. And so you see that this is pretty similar. The difference is just in the syntax, because now calc_age is not a regular variable like here, but it's a property of the Jonas object. And so therefore we use the colon here, but the rest here is exactly the same. And so that's why it was very important that you understood what a function expression actually is. Because here we need the function expression to create this method. And that's what this function is called. So any function that is attached to an object is called a method. So of course we could have not used a function declaration here. So something like this. So function calc_age, for example, that would not work. We would certainly get an error here. So unexpected token function, because this is a declaration. And so it doesn't work here. Here we need an expression. And so this will work indeed. Okay, does this make sense? So if you can think of functions as simply being values, then you can see that a method is actually also a property. It just happens to be a property that holds a function value. So here we have a string value, here we have an array value, here we have a Boolean value, and here we have a function value. All right? So I hope that's logical. And now, just like we can access any other property, we can also access the calc_age property or method. So Jonas.calc_age. And so calc_age is now the function value. And just like any other function, in order to call it, we use the parentheses. And now we can pass in the year here. And so that should then calculate our age. And let's just log this result to the console here, just to see if everything works. And it does indeed. Okay. And you could also have accessed this method using the bracket notation. Because again, it's just as if it was a normal property. And the brackets would actually be necessary here, so that this then here is the function, and then we call the function using the parentheses. So let's try that. And yeah, here this needs to be a string. So like I showed you in the last lecture, and now here we get 46 as well. Okay, so just like I showed you in the last video with the operator precedence table, the first thing that happens here is that Jonas.calc_age is computed. And so this here will become the function value. And then with the parentheses, we call that function value here and pass in 1991. And the same thing here. So here we access the property calcH using the brackets, and then this here will basically be replaced with the function, and then we call the function right here, just like before. All right. Now you might have noticed that the birth year 1991 that we passed here as an argument to the method is actually already defined in the Jonas object itself up here, right? So we already have this information in the Jonas object. And so writing the same number here and here is not ideal, because we might make a mistake and pass in the wrong year. For example, right here. So Jonas's birth year is 91, but here we could, for some reason, accidentally do 92, and then it would be wrong. And even if we do not make any mistake, this is still not ideal, because we are not keeping the code dry. So we're violating the don't repeat yourself principle. So if we know the birth year of Jonas, it should only be written in one place, not in multiple places. Because if that might change, then we have to change it everywhere. That's always the philosophy that we need to keep in mind. So what if we could actually access this birth year property directly from the Jonas object instead of having to pass it in? Well, it turns out that we actually can. And that's because in every method, JavaScript gives us access to a special variable called this. And so what we can do now is in this calcH function, we can read the birth year directly from this object itself without having to pass it in as a parameter here into this function. All right, so let me copy this and comment this one out just so that we keep a record of what we did. But this here will be the new version. So now we no longer need this parameter, and we will read the birth year directly from the object. And for that, again, we will use the this keyword. So the this keyword, or the this variable, is basically equal to the object on which the method is called. Or in other words, it is equal to the object calling the method. So let's see who is calling the method. So down here is calcH, and the object that is calling the method is Jonas, because that's where the dot is. And let's forget about this one. I'll actually comment it out here. And so again, the object that is calling the calcH method here is Jonas. And so that means that inside this method, the this variable or the this keyword will point to Jonas. And so let me just write this.birthyear here, and then I can explain it even a little bit better. So here we don't need to pass the 1991 here, and I will run this now, and we still get the correct result. So great. And to make this even more clear here, let's also log this to the console. And indeed, this is the whole Jonas object. And so again, that's because the Jonas object is the one who is calling this method, so this function. See here, it's jonas.calcH. And so whatever appears before the dot is the one who is calling the method. And so therefore, in the method, this points to Jonas now. And if this points to Jonas, then this.birthyear is of course this value that we have right here. Great. So you see that the this keyword is something really, really useful. And we will learn even more about the this keyword in greater detail in a later section. For now, I just wanted to introduce you to this concept. And I know this can be a bit confusing, so really make sure to maybe pause the video and really analyze what's happening here. Maybe you can even rewind a little bit and hear my explanation again. That might be useful too. Now, you might argue that maybe we don't even need this confusing this keyword. Why not just do Jonas.birthyear here instead? Well, because that would actually still violate the don't repeat yourself principle. It would work just the same here now, but then let's say that we need to change the name of the object. So we change it here to Jonas2, and then we call Jonas2 down here. And then the code will no longer automatically work. Because now Jonas is not defined, of course. And so we would have to keep that in mind and then come here and manually change this as well. While if we had the this keyword, then everything will keep working without us having to change it there. Because now this will simply point to Jonas2, because that is the object calling the method. And so therefore, it's always a good idea to reference the object itself and not hard-code the name of the object. So let's put it back to Jonas. And yeah, much better. So this works great already, and we're really going into some more advanced territory here. So I hope you're still following me and you're still making sense of everything. However, we can actually even take this a little bit further. But don't worry, it's not going to get a lot more confusing. Just a small variation of this. Because let's say that we need to access the age multiple times throughout our program. So that would be like calling this a couple of times. So let's say in 3 places of our application, we need to access the age. And so, of course, this will work. And indeed it does. And it always logs the Jonas object because we still have this here. So this makes it a bit easier to view. And so what happens here is that the function will get called a total of 4 times. And so this computation here will be done 4 times. And in this case, that's not a big deal, but it might be like a heavier computation that actually takes some more time. And so it would be a bad practice to do this multiple times. Instead, what we can do is to just calculate the age once, then store it in the object, and then when we need it at a later point, we can then just retrieve the age as a property from the object. So I hope you're following me here. So I will again copy this and comment it out so that we keep all the 3 versions that we did here. So what I was trying to say is that we can now use the this keyword also to store a new property. So we can say this.age is equal to this here. So we calculate the age, and then we create a new property on the current object. So in this case, on the Jonas object. And remember that we can use the dot notation like this to create new properties. So we did that in the previous lecture as well. Where was that? Yeah, right here. So here we created Jonas.location and set it to Portugal. And so here we are essentially creating Jonas.age and setting it to this age that we just calculated. And then we can simply return this age. And of course, we don't even need to return anything if we didn't want to. We could make this method only calculate the age, but not even return it. But I think it's a good practice to actually also return it. And so now here we can replace the function call with simply a request for the age property. And notice this trick that I did here again with the command D, right? So this gives me multiple cursors, and then I can do one operation in multiple places at the same time. So that's a really handy shortcut. So again, command D or control D, and in the menu bar, that means add next occurrence. So let's test this, and the result should be the same. And it is. But we only needed to calculate the age once. Then from here, we simply retrieve the property that we had already calculated before. And so this is the most efficient solution, let's say. All right. And now I actually have another small challenge for you that you can do just in this video. So I want you to write a method called getSummary, and this method should return a string which should kind of summarize the data about Jonas. Or, of course, any other person data that you might have used. For example, let me again, actually we can get rid of this. So let me write challenge here again, and then do an example string. So I want you to write, for example, this. Jonas is a 46-year-old teacher. And we now could actually add all the data here to the string, but that would be too much work. And I'm a bit lazy now. So let's just also say if I have a driver's license or not. So Jonas is a 40-year-old teacher, and he has a driver's license. And it says that I have a driver's license because has driver's license is true. But if it was false, then here it should say, and he has no driver's license. So it's either A or no. So figure out how you can do that. And so I hope you managed to do it. It's a bit similar to what we did in the previous lecture, but this time I want you to actually write a method on your own. So give this a try, and I see you here in a second. Okay, so let's add get summary. And remember that you need to have a comma between the properties. And so that's true also with methods. So here we need a comma, and then just a function. And it will then get all this data, of course, from the current object. So actually, let's first call this method. So, and we're doing it inside a console.log because, of course, we want to be able to see the summary string as a message in the console. So Jonas.get summary. Okay, so which is the object calling the method? It is Jonas. And so therefore, the this keyword inside of get summary will be Jonas. So I hope that this one is clear at this point. So let's now build a string here. And starting with the name, it is at this dot first name is a, and now the age. So this, and now what do we do here? Should we use the age property, or should we do calc age? Well, I would say that we should do calc age because we cannot assume that calc age was already called before. Okay, and if we don't call calc age before we call get summary, then the age property would not exist. And so it's better to actually do calc age here. And so I think we did this before. So in a template string, we can easily do a function call. That's not a problem at all. So this.calcAge will call this other method, and this will then return the age. All right. And maybe it might be strange for you to call the function also on this, but well, the rule is just exactly the same. This is Jonas in this object. And so this is essentially the same as writing it here. All right. So this will become the age. And so year old, and now the job, Jonas.job. And he has, and now we need to decide between a and no. So let's do a ternary operator here. So we get this dot driver's license. And basically, if it's true, then we want the result of this operator to be a. And if not, we want it to be no. And then driver's license. Okay, makes sense? So again, here we want either a or no, depending on the state of the has driver's license property. So we get that property by calling this dot has driver's license. And here we're using the ternary operator. And so if this first part is true, then the result of the operator will be A. And otherwise, the result will be no. And so that's what will then be put into this place of the sentence. Okay. And we already called the method down here, and we logged it to the console. And so I think this should work now. And it does. So Jonas is a 46-year-old teacher, and he has a driver's license. Now just to test, let's set it to false. And he has no driver's license. Beautiful. Okay. And yeah, that's all the code that I had to show you in this video. And now just to finish the lecture, which I know is already running quite long, but I want to basically build a bridge between this method and the array method lecture. So remember that we used methods on arrays previously. So we can quickly go there. So it was before this challenge. Yes, indeed. So for example, here we have friends.push. And so we have an array, and on there we call a method. So just like we did in this video. Now what this means is that arrays are actually also objects. They're just a special kind of object. And so they have functions, or in other words, they have methods that we can use to manipulate them, like push, pop, shift and unshift, and many more. All right. So in this lecture, we created our own methods on our own objects. But here we basically used built-in methods on arrays. And so once again, that means that arrays are actually also objects. That's why they can have methods as well. And we will dive deeper into why things work like this, but I wanted you to realize this early on in the course. This is quite a complex topic, and so there is really a very exciting journey still ahead of you. So I hope you're enjoying this journey so far. And now to test your knowledge, there is coding challenge number 3 coming up next. And here goes your next coding challenge. This time, number 3, for you to review all the material about objects. And I hope that you're really doing all these coding challenges, because as I mentioned earlier, they are really, really important for your progress. And I designed them all very carefully to exactly match the progress of the course and place them in strategic points of the curriculum. So I cannot stress enough how important it is that you do these challenges. Even if it's a bit difficult, but that's why they are called challenges. They are really to challenge you and to make you think, and if necessary, spend half an hour or 1 hour even to really try to figure out how the code works. Without coding on your own, it's impossible to learn programming, believe me. But anyway, let's now get to the challenge. And in this one, we're going back to Mark and John comparing their body mass indexes. And this time, we're going to use objects to implement these calculations. So here we have the formula again to calculate the BMI. And so your tasks are, first, for each of them, so for Mark and John, create an object with properties for their full name, their mass, and their height. So their full names are actually Mark Miller and John Smith. Then create a method called calcBMI on each object, which will then calculate the BMI based on the data that is on the object. So create the both method and add the exact same method to both objects. So write this method first in one of the objects and then copy the exact same method without changing it to the other object. And this method should store the BMI value to a property, and it should also return it from the method. So a little bit like the calcH method that we did in the previous lecture. Then log to the console who of the two has the higher BMI. And this string should look like this. So it should include the full name. And actually here it's not the full name, but do include the full name. That's why we have it. So John Smith BMI is higher than Mark Miller's. So not Killer's, but Mark Miller's. And then also include the actual BMI value here. And here is the test data, and I believe it's the same data as before. So good luck with this challenge. And again, it might be challenging, but please give it a try anyway. Okay, so I see you here in a minute, or maybe in half an hour, who knows? It doesn't matter how long you take. Okay, so let's get to work. So, number one is creating an object for each of them. So object Mark. So full name property Mark Miller. Then the mass, which is 78 kilograms, and then the height, which is 1.69 meters. So that's it for now. And now I'm just gonna copy this. As always, I'm a bit lazy, and that's just how programmers are, I guess. So John Smith, and he is 92 kilos and 195 meters tall. Okay, so that is point number one. And now we will create the calc BMI method. And then a function without any parameters, because we will take the data directly from the object, just like we did it with the calc_h method previously. And remember that it says here that we should store the BMI value to a property and also return it from the method. So this means that we will do this dot BMI and then do the calculation here. And remember, from the formula, the BMI is calculated by this dot mass divided by this dot height squared. So exponentiation operator with 2. And then also return it. So this dot BMI. And just to see if this actually works, let's actually call this method. So mark.calc BMI. And now I will quickly log to the console the property that we just created. So I could have logged this to the console directly, but I want to do it this way now, and it doesn't really matter. So with this, remember, we created a property called BMI. And so that is now, of course, accessible here. So mark.bmi, because remember that here in this method, this now points to Mark, because that is the object that is calling the method. And therefore, this .bmi will be on Mark. So mark.bmi equals mark.mass divided by mark.height. And so that's how we get this data into this method. All right, so that's essentially what we learned in the last lecture. And so here I'm doing the same. I'm first calculating this value, and then I'm doing mark.bmi, which was added here in this method call. Of course, without this method call, mark.bmi would not be available, because this method here doesn't call itself. We need to explicitly call it. Now console, missing the .log. How can that still happen after all these years? Okay, so here we get the BMI of 27, which seems about right. And now, as I said, we will simply go ahead and copy this method exactly the same to this John object, and it will work just the same. Believe me. So let me show that to you. So now we call John.calcBMI. And so now the object calling calcBMI is John. And so now in this method here, this will point to the John object. And so this time, John.bmi will be calculated using John's data of mass and height. Okay, are you still following that? As always, you can pause the video, analyze the code on your own, or you can always rewind to hear the explanation again. I actually like to do that myself when I watch other online video courses. So I think that's a good tip, maybe. Anyway, so we just calculated the BMI of John here as well. And so now I'm logging both to the console. And so, yeah, this one also looks correct. And so this means that simply copying this method from one place to the other actually makes it work and adapt to the data of each object. Now, having the exact same code in both of these objects kind of violates the don't repeat yourself principle, right? And actually, there is a way in which we can avoid this. And of course, we will learn how at a later point in the course using something called object-oriented programming. But for now, we are still learning the basics and just want to make things work. And of course, have some fun along the way. So this was the hardest part, I believe at least. Now all we have to do is to write this string here. Let me actually copy the example so we have it as a reference down here. Otherwise, I'm going to get a bit lost. So, if mark.bmi is larger than john.bmi, then console.log. So let's get the full name now from the object. So mark.fullname BMI. And now we also need it here in these parentheses. So let's put it there. Mark.bmi is higher than, and now let me just copy it here. So, and again, I'm using Command D to select the next occurrence, and then let's just replace it with John. So Mark's BMI is higher than John's BMI. And now let's grab this again. Else, if John BMI is larger than Mark.bmi, then essentially say the opposite. So here it's going to be John. And again, Command D. And here it's going to be Mark. Okay. So 27 is higher than 24, and that 27 belongs to Mark. And so this seems to be about right, but it's not completely right. So, of course, here it should be lowercase. So BMI, and now I cannot use the Command D because then it will select this one as well. So I'm double clicking on this one, and I hope that you're finding these VS Code tips useful as well. So I'm clicking, or actually I'm double clicking on this one. Then I hold down the Command key, which in your case might be the Control key or maybe the Option key. So I know there are different configurations for this, and it might not even work for you. So please don't ask any question in that case. But for me, I just have to hit Command, and then I can double click on multiple words, and then all of them get selected. So now I have these 4 multiple cursors here again, and I can simply delete all of them and write the one that I'm interested in. So that's the lowercase BMI. And now we get the correct values. And also this conditional logic is correct as well. And so with this, we did actually solve the challenge. And with this, we also finished this introduction to JavaScript objects. And once again, I really want to congratulate you for the progress that you're making here. Great job and really well done. And I really mean it because I know how hard it is to stick to a course like this and to learn a completely new thing that is probably a bit confusing for you at this point still. just keep in mind that that is absolutely no problem at all. And actually, in the next section, I believe, I have a video about how to learn, basically. So about learning how to code. And there's a lot of great tips that I'm sharing there. So once you reach that, make sure to watch it carefully. But now, anyway, I will leave you to review this lecture if you want, or to move on together with me to the next video, where we're now going to start talking about loops. When we talked about the if-else statement, I mentioned that it's a control structure, and also that there are more control structures, right? Well, one of the other control structures are loop. And so loops are our final big topic in this JavaScript fundamentals section. So loops are a fundamental aspect of every programming language, because they basically allow us to automate repetitive tasks. So tasks that we have to perform over and over again. And here I like to use the analogy of a gym. So when you go to a gym, you might, for example, lift weights, right? And let's say that you do 10 repetitions of a certain weightlifting exercise. So we could represent that by doing something like this. So lifting weights repetition 1. And then some more emojis here. Okay, so repetition 1. And remember, we want 10 repetitions. So we would have to paste this code here 10 times. And I don't know even if this are 10 times or not. But anyway, you can start to guess that this is probably not a best practice. Just imagine that we had 30 repetitions instead of just 10. And then if we wanted to, for example, change some word here in this string, then we would have to change that in all of them. So this really violates the don't repeat yourself principle, right? Because we're basically repeating the same code here 10 times, and all we're changing is just this number. So instead of doing all this, we can now create a loop and then put one of these lines of code in there, and the loop will then run that code over and over again until we tell it to stop. And so let's implement a so-called for loop now. And that's a loop which has a counter. So let's do that. And we simply write for and open parentheses. So a little bit like the if statement, and this is a for statement. And so it looks similar. Now the loop statement has 3 parts. The first part is the initial value of a counter. And in the case of this current example, the counter is the value that will start here at number 1 and go all the way to number 10. So let's call this counter rep, which stands for repetition. And so here we literally create a variable called rep. And we start it at 1 because, well, that's our first repetition. Okay? And here we need to use a let variable because this counter will later be updated by the for loop. So that's the first part of the for statement. Then we use semicolon and go to the second part. And the second part is a logical condition that is evaluated before each iteration of the loop. So before each time that the code in the loop is executed. So let me just write it here first, and then this will make more sense. So our condition will be rep needs to stay below or equal 10. So again, this condition that we just described here will be evaluated before each iteration of the loop. Now, if the condition is true, then the next loop iteration will run. But as soon as this condition is false, then the loop stops. And so no more code will then be executed. So basically, the loop will keep running while this condition stays true. And this is really important to realize. And let me actually write that down here for you. So for loop keeps running while condition is true. So this is the kind of notes that I hope that you are taking throughout the course, but this one is really important, and so I wanted to write it down. Okay, and so now I hope it makes sense that we have this condition, because in each iteration of the loop, the rep counter will get increased. And so at a certain point, it will reach 10, and with 10, this condition is still true. So 10 is still less or equal than 10. But then after that, it will be 11. And so then repetition is no longer less or equal 11, and then the loop will stop. And at that point, we will have printed these 10 strings, basically. So let's continue writing this so that in the end, we actually make that work. So speaking of increasing the counter, that is actually the third part of the for statement. So another semicolon here. And now here we actually update the counter after each iteration. So that's necessary because right now the counter would just stay at 1 forever. And so this condition here would never be false. And so what we do here is to now increase the counter by 1 after each iteration. So we can say rep equal rep plus 1. But does this look familiar to you? So basically increasing the value by just 1. Remember that in the last section, we actually learned about a special operator which does just this, but in a much simpler way. So instead of writing rep equal rep plus 1, we can simply write rep plus plus. And so this will take the rep value and increase it by 1. All right. And now all we have to do is to write the code that we want to be repeated. And so let's copy this string here. Okay. And let's say 1, and then it will print this string 10 times. So let's start with that. And then afterwards, I will show you how we can actually update this number here. But for now, let's try this out. And actually, let's comment this code out so that it doesn't get in our way. So command / for that. And let's go. And indeed, we see that the string was printed 10 times. That's what this 10 here stands for. So the DevTools will not print the same string 10 times. It will simply put this 10 here. But what matters is that this logic here actually worked. So now let's actually use this counter variable that we created here to actually increase the number in the string that we're printing out. So how do you think we will do that? Well, it's actually simple. All we have to do is to replace this number here with the current value of the counter, because this variable that we defined here, so this rep variable, it's just a normal variable, and it's going to be available here inside of this code block. So let's transform this to a template string so that we can then insert that variable into the string. So we get rid of the hard-coded value, and now we basically dynamically build the string. And so here, all we need to do is to put the rep variable. And now we get exactly what we wrote here manually in the beginning, right? So that works. And so let's recap exactly what we did here. So we wanted to log our string here, so a string like this, 10 times. But of course, it could be any other repetitive operation. Again, we're just using console.log here so that we can see the result in the developer console. Anyway, in order to solve this problem of not having to repeat the same code over and over again, we used a for loop. And so we initialized the counter of the loop at 1. So right here, we created this new rep variable, and rep again stands for repetition, but it could be any other variable name, of course. And so we started at 1 because, well, we wanted to start at repetition number 1, but we could also start, of course, at repetition 5. So let's see how that looks like. And then, as you might have expected, the first repetition that's printed is the number 5. Okay, but let's put it back to 1 now. So after each iteration of the loop, we then increase this counter value by exactly 1. And this happens by the end of the iteration. So in the first iteration, this string here is logged to the console with the current repetition, which stands at 1. So this here will be replaced by a 1, and then afterwards the rep counter will be updated to 2. Then in the next iteration, this same string here is printed, but now with rep at number 2. Then rep is updated from 2 to 3, and so on and so forth. And these loops keep running while the rep variable is less or equal 10. So basically, while this condition here is true. And that's how we achieve exactly 10 repetitions. So what the loop does is to verify before each repetition if our condition here still holds true. And only if it does, it will keep running the loop. So it will execute the next iteration. And so it will execute this block of code here one more time. And of course, we could change it to something else. Let's put it at 30. And then we should get, indeed, 30 repetitions of the same string where only this counter here is changed. All right. And in a nutshell, that's how the for loop works in JavaScript. In the next few videos, we will see some more useful applications of the for loop and also talk about another type of loop that we have in JavaScript. Let's now explore some more features of the for loop and also create a somewhat more useful example. And one of the most used applications of for loops is to loop through arrays. So let's get back the array that we were using before. So where is that? So I mean the one where we talked about objects. Yeah, this one. So go to this lecture about Introduction to Objects and then grab this Jonas array. And maybe you didn't write it back then, but then you can just write it right now. Okay, and so now we can use a for loop to loop through this array. And let's say for now that we wanted to individually log every element of the array to the console. So very simple. All we want to do is to log these 5 elements here. So let's write a for loop. And as always, we start with the counter. So let, and now a traditional counter variable name has been I for a long time. And so let's use that here as well. So just I, and this time we need to start it at 0. And that's because the array is 0 based when it comes to reading elements out of the array. Remember? And this will make sense once we actually write the code of this loop. Let's now actually skip the condition for now. So we're going to deal with that a little bit later. And so now updating the counter is going to work exactly the same as before. So since we want to log all of the elements, we need to update the counter variable simply by 1. And so again, we use ++. Okay, and now let's write our loop here itself. So console.log. And remember, all we want to log to the console is each element of the array. And so without the loop, we would write that like this. So Jonas 0, right? And then let's do that outside. So we would do this, this, and then all the way to number 4, right? So let's comment this out, but this is helpful to see what kind of code we want to achieve. So again, we want to start at Jonas 0, which is the first element. Jonas 1 is this one, then 2, 3, and 4. And so that's the reason why we started the counter at 0, because that's the first element that we want to get. It's Jonas 0. And so here, instead of hard coding the 0, of course, we are going to use our counter variable. So, and that's I. And now the trickiest part here is the condition. And so that's why we left it for the end. But now we need to actually tackle it. So, for how long do we want to keep this loop running? Well, it should run when I is 0, right? It should also run when it's 1, 2, 3, and 4, because 4 is the last element. But when it's 5, it should no longer run, right? And that's because Jonas at 5 does not exist. Let's just write that. Does not exist. And so that means that the I counter variable should always stay below 5. So let's write that here. So I should stay below 5. And so with this, as soon as the counter variable is updated to 5, then the next iteration of the loop will not run anymore. So let's try this. And here it's of course not Jonas, it's Jonas array. So let's actually change the name up here in the array itself. Try that again. And yeah, we get a log of each of the elements in the array. So all of the 5 of them. Great. But there's actually still one problem with this, which is that we hard-coded the length of the array here with 5. So let's now say that we add another element. Let's say just true. And so if we try this now, do you think that true will be logged here as well? Well, it will not, because of course we are still telling JavaScript that I should stay below 5. And so it will not print the array at position number 5, which does now exist. So now we do have Jonas at position 5, right? And so the solution to this is to not hard code the value here, but to compute this value. So basically to get it from JavaScript itself. And how can we get this number? Well, actually this 5 is simply the length of the array, right? Not of this one anymore, but of the original one. So this array has a length of 5. And so 5 is exactly the number that we put here. And so we can simply replace the hard-coded value with a dynamically calculated one. And that's Jonas.length. Remember? So let's try that. And indeed, it still works. And if I now go back to adding something else, like true, then Jonas.length will now be 6. And that of course happens automatically, and we don't have to manually change any code in that loop. So now indeed true also appears here in our log. Great. Let's now also log something else here. Let's say the type of the variable. So type of Jonas I. And I hope that this part here makes sense. So the fact that we're using the counter variable here to retrieve all the elements of the array. So now let's say, so string, string, number, string, object. So remember how I said that an array is in fact an object, and here we have the proof of that. And then finally the last one is of course a Boolean. Okay, so I hope that this logic here made sense. And so this is, in a nutshell, how we loop arrays using the for loop. Now what we did here was only to read values from an array. But now let's also at the same time create a new array which will contain this type of each of the elements. So basically this. All right. So again, what I want to do now is to create a new array which will contain all the types for all these elements. And if that sounds a little bit useless, then just keep in mind that these are all just educational exercises. So I designed them to show you how these different features of the language work. So in the real world, we would probably not create an array with types of variables. But this is excellent to show you how to create a new array based on the values of one original array. So to do that, we start by creating a new empty array outside of the loop. And let's do that here after this one. So I will call this one types. And now I think this is something we didn't do before, which is to simply create an empty array. And all we have to do is to basically create an array with the usual syntax, but without any element inside of it. And so now we have to go here to the same loop, because this new array types will be based on the Jonas array. So it's going to have the same length. And so we can use the exact same loop that we used to read data from the Jonas loop, also to construct this new types array. So let's say types at position I should be equal to type of Jonas at position I. And remember that this works because we can essentially do this. So we could do it again without the loop and say types 0 is equals string. So this would work, right? And so of course it also works with the index number here dynamically. And so that's exactly what we're doing here in the exact same way as we read data from the Jonas array. Right? So in iteration 0, we will have type 0 equals type of Jonas 0. Then in the next iteration, we will have types 1 equals type of Jonas 1, and then 2, 3, 4, and 5. All right. So just to see if that works, let's then log to the console this newly created, or to be more accurate, this newly filled array. So let's see. And indeed, now we get this array, which has exactly the types that we can see here as well. So string, string, number, string, object, and Boolean. So these 6 that we also have here, which means that we achieved our goal here. Now, this is just one way of filling an array. And let me write that down here. Filling the types array. And here we do basically reading from Jonas array. But this is just one way of doing it. So let's comment out this one and do it in another way. And do you remember how to add elements to an array in another way? Well, we could use the push method, right? So that would be types dot push. And remember that push adds a new element to the end of the array. And so here we now need to pass in the element that we do want to add on to the array. And so that's again type of Jonas at position I. So of the current counter. And so if we try this now again, we should get the same. And it's important that we add the new element to the end of the array and not to the beginning. So we really need to use push here and not unshift. So I think that this way of doing it here is actually a little bit cleaner. But if you prefer this first way here, then of course you can just use that one as well. But what matters here is that we really understood the logic of how to construct all the different parts of this for loop in order to loop the array. So it starts with the counter being 0 because that's the first element of the array. And then this condition here, which specifies that the current index always needs to stay below the length of the array that we're looping through. And then in the loop itself, we always get the current element using the current counter, which is going to go from 0 to the length of the array minus 1, basically. All right. And to make sure we really got this, let's try another, maybe more practical example. So let's go back to having an array of birth years. So 1991, 2007, let's say, 1969, and 2020. And now what we want to do is to calculate the ages for all these 4 birth years here. And we want to store them in a new array. And that's a very common type of operation, which we actually already did before, but without using loops. So essentially that's what we did in the tip calculator challenge. So yeah, here. So here we had an array of 3 builds, and then we manually calculated the tip for each of them. So manually we specified the index 0, 1, and 2, and created a new array based on these values. But in the real world, we would have used a loop to do that. And so that's what we will do now. Okay, just with another a bit more simple example. Years is the array which contains the birth years. And now let's create another, and again, empty array, which will then hold the ages. And so what we're going to do now is to loop through years and then fill up these ages array. So, for, and then once more, let's define the counter at 0 for the same reasons that we did it before. And it's not a problem that this counter variable here has exactly the same name. Then the condition is also going to be the same. And actually the whole loop always kind of looks the same when we loop over an array. So now here the difference is that it's of course years dot length. And then at the end we, as always, increase the counter by 1. And now what we need to do is to calculate the age of the current year. So that's going to be 2037. So as always, that's the year that we're currently in, let's say, and then minus the current birth year. So how do we get that? We say years at the current loop position. Okay, so that's nothing new, I hope, now at this point. Okay, so we have this calculation now, and now we want to add it to this new empty array. So we say we want to push it to that array. And so we use the push method to do that. So ages dot push. And so this is the value that we want to push into this empty array. And that's actually it. So let's check it out in the console. And here we go. So just to confirm, 2037 minus 1991 is of course 46. And let's just do it with 27 as well, 2007, I mean. And so that's 30, which is this one. And so this array result is correct indeed. So what we essentially did is this. We cannot do operations between simple values and an array. So that I showed you earlier, right? We cannot do 2037 minus the years array. That will just give us not a number. And so here in this loop, we basically did it individually. So we did the calculation one by one. In each iteration of the loop, we calculated 2037 minus this year and then added it to the first position in the ages array. Then we did 2037 minus this and put it at the end of the ages array again. And then the same for this one and for 2020. Great. So that is a very, very useful and important application of the for loop. And now to finish, let's learn about two important statements for loops. And that's the continue and the break statement. Let me just write that here. Continue and break. And let's start with continue. So continue is to exit the current iteration of the loop and continue to the next one. On the other hand, break is used to completely terminate the whole loop. So let's see two quick examples for that. And let's go back to actually this first loop that we had here, where we looped this Jonas array. So I will just copy this because we already learned how to loop through the array. And now I'm just interested in showing you how continue and break work. So let me delete this and this as well. And now let's say that for some reason, we only wanted to print elements to the array that are strings. And the continue statement is perfect for this. Because again, with continue, we can exit the current iteration of the loop. So what we can do here is to say, if the type of the current element, so of Jonas I, is not a string, then continue. And so that's how we write the continue statement. It's really just this continue keyword. So again, what we want to do here is to only log strings to the console, which means that everything else should basically be skipped. And that's what we do here. So we say if the type of the current element, so that's this one here, so if the type of the current element is not a string, then continue, which again means that the current iteration of the loop is exited and then the next one starts immediately. So let's just write some other note here to the console just so we know what we're doing here, like only strings, because otherwise the output here is going to start to look a little bit confusing. But anyway, let's test this now. And indeed, we only get strings now. So these three are strings and all the other ones are not strings. So this number, this array, and this boolean, so they will now not get printed because we basically skipped them. For example, that age number, which is 46 here, so the third element, does have the type number here, right? So it's not a string, and so this here will be true because, of course, number is different than string. And so this is true, and so this code here will run. And what continue will do is that it will immediately exit the current iteration. And so this line of code here will not be executed in the current iteration. It will not even be reached. Okay? And now finally, let me just show you how break works. And remember that what break does is to completely terminate the whole loop. So not just the current iteration. So what we want to do now is to log no other elements after we found a number. So essentially, after a number is found, which will be this 46 here, nothing else should be printed. So let's do that. And I will again copy all of this. And so let's say here, break with number. So let's translate the logic that we just said into the code. So as soon as a number is found, we want to break the loop. So our if condition here should be type of Jonas I, so the current element, if it's equal to a number, so now that's number, then break. Now, okay, let's see the result here. And indeed, that's exactly what we wanted. So after the first number is found, which is this 46 here, nothing else is printed. So in this iteration, where the number is found, not even this line of code is printed anymore, and then the loop is terminated completely. All right, now this might not sound very practical, but believe me, there are some important use cases for continue and break. It's just hard to create some small and isolated code examples to show you just how useful they can be. But anyway, I wanted to let you know that continue and break exist. But the most important takeaway from this lecture is definitely to understand how we can loop through arrays using this kind of logic here. Okay, so this one here is really important that you understand this snippet of code. In this lecture, we're going to do two interesting things. First, we will loop over an array backwards, and then second, we will also create a loop inside another loop. So let's have some more fun with arrays now. And so let's get back our array again here. So the Jonas array, and let's forget about this element here. And so now, as I said in the beginning of this video, let's now loop over this array backwards. So the first element that we want to print is this one, then this, and finally Jonas. So essentially, in the last lecture, we looped from the beginning. So we started with index 0, then 1, all the way to 4, right? But now we want to start at 4. Then we want to go to 3 and all the way to 0, which is going to be the last index. So this one is 4 and this one is 0. And so now we need to create the for loop according to this new information. So basically according to this new methodology. So let's start again with the counter, and I will name it I again. But now what should be the initial value of the counter? And we already replied to that question kind of. So it should be 4. But should we just write the 4 here? No, we shouldn't, right? Because we already learned that hard-coded values like this are not a good idea. So what is 4? Well, 4 is basically just the length of the array, which is 5 minus 1. So that's exactly what we will write here. Jonas.length minus 1. Then the condition. And when do we want the loop to stop? Well, it should stop after the 0. And so the condition we need to write, remember, is telling JavaScript in which condition the loop should keep running. And so basically the loop should keep running as long as the counter is still above 0. So I should be greater or equal, actually, 0. So let's quickly simulate that. So at number 4, which is in the beginning, I is greater or equal 0, right? So this condition will be true. And so the next iteration will run. Then we need to decrease the index or the counter. And so let's actually do that as well. And so instead of using I++, which we used before to increment the value, we use minus minus to decrement or to decrease the value by 1. And so now we move from 4 to 3. And 3, of course, still is greater or equal 0. Then all the way to 0. And so 0 is still greater or equal 0. Then the counter gets updated again, and it will be updated to minus 1. And now minus 1 is not greater or equal 0. So this is false, and so the loop will stop. Okay, so I hope that this was not hard. Really, all we have to do is to think when we create these 3 parts here of the for loop. And I hope that you could follow my train of thought here. Now anyway, the rest, of course, is going to work just exactly the same. So we're getting, again, the current element. So let's check that very quickly. And yes, great job, it works. And just to really show it, let's also log the counter variable itself. So first the I, so the counter, and then the array value. And so indeed, this works just as we intended. We start with number 4, just as we have it here. And then we move to 3, 2, 1, 0. And if we now edit one element, then for sure, this is going to work just the same. Because now Jonas' length is 6 and minus 1 is 5. And so it will start here at true. And indeed, it does. All right. Now you will probably not be doing this all the time in your own code, but I thought that this was a nice exercise so we could again think about how to define the counter, the condition, and the counter update. Okay, so that was the first part of this lecture. And now I want to show you how we can create a loop inside of a loop. So does that sound crazy? Well, it's not so crazy. And it's not so difficult either. And to do this, let's go back to our gym example from the first loop lecture. So there we had 10 repetitions for a certain weightlifting exercise. Remember? But now let's say that we have 3 different exercises and we want to repeat each of them 5 times. So that means a total of 15 repetitions, 5 for each of the 3 exercises. So to log all these exercises, we will need a loop inside a loop. So let's roll up our sleeves and get to work here. And we're going to start with the 3 exercises. So let's create a counter, and I will actually call it exercise. So exercise, and we start at 1 now this time again, because we simply want to log exercise 1, 2, and 3. So our condition here is that the exercise should be less or equal 3. And actually, this would be exactly the same as writing exercise below 4. So you can do whatever you prefer most. And I think I will actually stick with this one this time. And then we need to increase the exercise after each iteration as always. So now let's log to the console something like this. Starting exercise, and actually here we want to include the exercise number. So let's instead create a template literal. And so here we use that counter variable. So let's just check this one. So we have 3 exercises, but we don't have any repetitions yet in there. And so now, again, we need to create a loop inside a loop so that in each exercise, we can have the 5 repetitions that we want. And the repetitions themselves are a loop, right? And so that's why we now need that loop inside of this loop. So let's do that. And this is going to be basically the same as we did earlier. So let's again call it rep, start at 1, and then the condition. So remember how I said that we want 5 repetitions this time. And so let's say we want to stay below 6. So again, that would be exactly the same as writing less or equal 5. But let's keep it a bit different this time and say below 6. And then rep plus plus. And now lifting weights, repetition. And again, I forgot to make this a template literal. So yes, this should work much better. And now this cute emoji here again. Oh, where is it? And let's test this now. So what do you expect to see? Think about that before you load your own result or before I load here the result. So, is this what you expected? Let's even increase this here a little bit. And now we see the full picture. All right, so we start exercise number 1, which is what we have here. And then inside of this iteration of exercise 1, a new loop is created and executed. And so that's what then creates this lifting weights repetition from 1 to 5. All right. Then this loop here is finished, right? So it run all the 5 times, and then this first iteration is finished. And so the exercise loop, so this outer loop here, goes to its second iteration. And so we are at exercise number 2. And then this whole loop here will run again from 1 to 5. So that's these 5 here. And then that loop again finishes. And then the exercise iteration finishes. And we go to iteration number 3. So exercise is now number 3. And then the whole repetition loop, so this inner loop here, will run 5 times again. And with that, we end up with a total of basically 15 repetitions, just as I said in the beginning. So 3 times 5. Okay, and we could even include the number of the current exercise in this string that we're printing here. So let's do that as well. Exercise, and then exercise. So this is the variable that we get from the outer loop. And so this variable here is of course available inside this whole loop. And that does include all the inner code, even this inner loop. And so that's why we can access this variable here as well. And so now we should see exercise 1 printed for these 5, then exercise 2 printed for these 5, and exercise 3 for the last ones. And yeah, beautiful. All right. I think this was a very fun exercise. And again, even though you might not use this all the time in the real world, I still think that this was a pretty cool example to show you some more power of loops. And now to wrap up this section, all there is left to learn is another type of loop, which is the while loop. All right, so we learned all about the for loop and even created a loop inside a loop. But there is another type of loop in JavaScript, and that's the while loop. So let's explore that one now. And to understand how the while loop works and the difference between the for and the while loop, let's actually go back to our first for loop lecture and get back the code of this weightlifting exercise. So just copy this and we will keep it for comparison basically. So let's put it back to 10 here as well. And so let's now do the same thing with a while loop. So implementing the same with a while loop, we still need the same components. So we still need a counter so that we can then actually print the current value to the console. We still need a condition so that we know when to stop, and we still need to increase the counter somehow. Now in the while loop, it works a bit differently because for the while loop, we can only specify a condition. So while, and then just the condition is the only thing that we can specify here. So that's going to be exactly the same as this one. So we want to keep the loop running while repetitions is less or equal 10. And that's actually why this loop is called while. So again, it's called the while loop because it will run while this condition is true. All right, but now we need to kind of manually, so more explicitly define the other two components of the for loop. So the repetitions and the increasing of the counter. And so we need to do that basically outside. So we start at the beginning with rep equal 1. Then we have the condition. Then let's put the code that we want to execute. And then at the end of the iteration, we will then increase the counter. And so let's just do that. So at the end of the iteration is basically the end of this code block. And so let's do that there. And that's it. And so now we should get the exact same result twice, once coming from this for loop and once coming from this while loop. And yeah, so 1 to 10 and then again 1 to 10 coming from the while loop. Just write that here just to make 100% sure. Yeah, and indeed, the second set here is coming from the while loop. So this all means that the while loop is more versatile than the for loop, which means that it can be used in a larger variety of situations. And that's because it does not really need a counter. So we put the counter here because we need it for this specific use case. But all the while loop really needs is the condition, which needs to stay true for it to keep running. And that condition can be any condition. It doesn't have to be related to any counter at all. And sometimes that's exactly what we need to solve a certain problem. So a problem without any counter. So without a number that is increasing. And so let's create such an example here. So I will start by taking off this for loop. We no longer need that one. And now we will do a simple example that does not depend on a counter, but instead it will depend on a random variable. Okay? So what we're going to do is to basically roll a dice and then keep rolling the dice until we roll a 6. And then when we roll a 6, we stop. So essentially, we will want to keep running the loop while the rolled dice is different from 6. And so in this case, we do actually not know beforehand how many times the loop should run. And so we don't need a counter variable. And that's exactly the use case of a while loop. So let's start by creating that random number. And so the roll of a dice is a number between 1 and 6. The way that we implement this does not matter at this point. Okay, we will learn more about random numbers at a later point. And so for now, basically just type what I am writing here. So we're using math.random, and this will create a number between 0 and 1. Then we multiply that by 6, but this is going to be a decimal number. Let me just show that to you quickly, because I think this is still interesting for you. So you see that it's a decimal number, and so now we need to get rid of this decimal part. And so that we do using math.trunc. And so this will give us a number between 0 and 5, and then we add 1 and get 1 to 6. So again, don't worry about the implementation of this at this point. We will do this again later. But what matters here is that as we reload the page, we get a random number here that is different every time. And so it will be different for you, of course. So different from what you see in the video as you keep reloading your own page. Okay, and so now let's do what I explained earlier. So again, we want to keep running the loop until we roll a 6. So until this dice variable here holds the value of 6. And so the condition of the loop is now going to be dice different from 6. And as soon as the value is 6, it will stop. And let's log the value to the console here. So you rolled a and then dice. And so let's get rid of this one here. And now let's log it to the console. But keep in mind that actually right now we are only creating one dice value. So at this point the loop doesn't make a lot of sense. And so actually let's keep working on this before we test it. So again, we are only creating one random number between 1 and 6 here, right? And if that's different than 6, this loop here will run. But right now, the loop would then run forever, which I'm not going to show you here now because that would crash the browser. So this would be called an infinite loop, and we don't want that. So what we will do is to keep creating new dice values. And so we are going to reassign this value at the end of each iteration. And so now we're ready to test the result here. Whoa, you see we got a lot of dice rolls here. Let me actually also comment out just this console.log here. And so of course your result will be different from mine because we are using different random numbers. But anyway, let's analyze what happened here. So we start with some random dice number, and then here we check if that dice is different from 6. And apparently it was different. And so then we entered the loop, which then logged you rolled a 2. So my random number was first a 2. Then in the next line, we created a new random number, and then the loop ran again. So again, this condition was tested. So is the dice different from 6? And apparently it was. And so we entered the loop again. And so it printed, you rolled a 1. And then the next dice was a 5. And then the next one was a 4. But then apparently the next dice that was rolled here was a 6. So at the end of this iteration here, this dice value was a 6. And so then in the next iteration, dice was actually equal 6. And so then the condition is no longer true and the loop stopped. And let me actually write one more line of code here in which we can say if dice is 6, then log loop is about to end. And so this way we can know when a 6 happened. And so the very first thing that should ever happen here in this output is this, right? Because then when the dice was 6, the next iteration will no longer run. So let's do that. And indeed, so we get 1, 5, 4, 1, but no 6. And then loop is about to end. And so the dice was 6. And so this condition was true. And so we saw this log to the console. And then in the next iteration, again, 6 equals 6. And so the loop finished. Let's try some more times. And of course, it works. Oh, and now we get the situation where the first dice ever was a 6. And so the loop never even started. And this was the situation I was waiting for here. So when dice is 6 right away in the beginning, then of course this loop will have exactly 0 iterations. It will never start. Okay? And so the conclusion of this is that the while loop does really not have to depend on any counter variable. So whenever you do need a loop without a counter, you can reach for the while loop. So basically, that happens whenever you do not know beforehand how many iterations the loop will have. So in that situation, the while loop is the right tool for the job. And that's exactly what we had here. So we had no way of knowing how many times we would roll a dice that's different from 6. Now, on the other hand, when we do know how many times the loop will run, that means that we're going to actually need a counter. For example, when we want to loop over an array, we already know how many elements that array has, and so we know how many iterations we will need. And therefore, the for loop is usually the right choice to loop over an array. All right, and with this, we kind of finished the JavaScript fundamentals. All there's left to do now is for you to complete the final coding challenge of this section. And here goes the final coding challenge of this section. And in this one, let's improve the tip calculator that we created earlier, but this time using loops. So here is what I want you to do. First, create an array called builds, which will contain the 10 test values that we have down here. Then create empty arrays for both the tips and the totals. And so these arrays should be called tips and totals. And if you need more details about this challenge, you can always go back to the code of the previous version that we wrote of this. Then in number 3, use the calc tip function that we wrote before. And so go back to that challenge really and copy the function from there. There's no need to repeat the same code. So use that function to calculate both the tips and the total values for every single bill value that is in the builds array we created in number 1. And to do that, of course, use a for loop just as we learned over these few last lectures. And my hint to help you a little bit with this in case you need it is to call the calc tip function inside the loop and then use the push method to keep adding values to the tips and the totals arrays. All right, so that's the basic challenge, and hopefully you can solve it even if you need to consult the code that we wrote earlier. That's absolutely no problem. So there's no need to memorize anything. All you need is to understand. And so if you understood what we did up until this point, you should be able to look at the code that we wrote and then change that in order to fit this challenge. Now, if you want to challenge yourself even more and basically push what we learned to the limit, then I have a bonus question. And here I want you to write a function calcAverage, which will take any array called R as an argument. And this function will calculate the average of all the numbers in the array that it received. Now let me tell you that this is a very difficult challenge for you at this point, because we haven't done anything like this before, okay? So if you don't want to get frustrated or something, then there's no need to try this one. You can just watch the solution at the end of this video. But if you still want to attempt how to do it, here are the steps how to solve it to make it a bit easier. So first of all, you will need to add up all the values in the array that the function receives. And to do that, you start by creating a variable called sum and set it to 0. And then you will loop over the array using a for loop. And in each iteration, you will add the current value of the array to the sum variable. And by doing this, you will end up with all the values in the array added together. And then to calculate and return the average, all you have to do is to divide the sum that you just calculated by the length of the array, because that is the number of elements. So for example, if the array had just two values, like 10 and 20, we would add them together, they would be 30, and then divided by the number of elements in the array. And so that would be 2, and so the result would be 15. Okay, that's how you create the calc average function, and then I want you to use that function on the totals array. All right, so basically I want you to calculate the average of all the total values of the tips plus bills. Okay, so again, don't beat yourself up if this bonus one is too hard for you. Anyway, good luck with this one, and I see you here again in a minute. Okay, and let's start by grabbing the calc tip function from earlier. So that should be here. Okay. And that's why we keep all the code in one neat file like this. Next up, we create the bills array. And this one has quite a number of values, but we can just copy them. They're already almost in the correct format. So no and, but a comma. Then we create the empty tips and totals, const tips equals an empty array, and const totals another empty array. And now is where the magic starts. So basically where we will calculate the tips and the totals. So that is question number 3. So use calctip to calculate tips and total values. So essentially what we will do is to loop over the bills array and then fill up these two arrays. So for let I equal 0, and we want this to run while the counter is less than the length of the bills, which is 10, and so the last index is 9, and so that's the last element that's going to be taken. And now in here, let's start by calculating the tip and store it in a variable. So const tip is equal, and now we're using the calctip function. So we call it using parentheses, and now we need to pass in the bill value. And what is the bill value? Well, it is just the bills array at the current position. And now you might wonder why I am able to declare this tip variable here as a constant. Am I not changing it in every loop iteration? Well, actually that's not what happens. Actually, in each iteration, a new tip variable is going to be created. So we're not mutating, we're not changing the original tip that we declare here. In each iteration, we will simply create a new one. And that's why we can use const. Anyway, now we have the tip calculated, and so we just need to push it into the tips array. So tips.push, and here the tip. And finally, we need to push into the totals. So totals.push the tip plus the current bill. And we already know that that is bills Okay, and that's actually it. Now you could have done it in a different way. For example, without this variable here at all, you could have just put this code here and here. But then you would have calculated the value twice, and that's just not necessary. We just calculate it once, and then we use it both to push the value into the tips and into the totals. Okay, and now as always, let's check all the 3 arrays out in the console. And whoa, that's a lot of numbers. But just by quickly looking at them, everything looks correct. Great, that's really great. We basically just did the same as we did in the previous version of the challenge, but this time we did it using a loop instead of manually creating the array by calling calctip with builds 0, 1, and 2. So that's what we did in the previous challenge, but this one is a lot better. Because now, no matter how many builds we have here, the loop will take care of all of them at the same time, basically. Okay, so that's the basic challenge. I hope you arrived at the same result that I did, no matter how you solved it. And now let's go for the bonus here. So we're writing a function called calcAverage. So const calcAverage. And once again, I'm using a function expression here, which is my favorite kind of function, I would say. And as we said, we will receive an array, and any array here will work. So once again, we're building a generic function which does not care what kind of values it's going to receive. It can receive builds or tips or scores or heights or masses or whatever, really. It doesn't care what the values are. And that's also why I gave it this generic name. So it's just calcAverage and not, for example, calcAverage totals. Let's now do what we say, or what I say here in 4.1, which is to start creating a sum variable that starts at 0. Then as we loop over the array, we will keep adding the current value to that variable. So this time it needs to be a let, because this sum will of course be updated as we loop over the array. And now all of this is pretty standard at this point. So equals 0. I should stay below the array dot length. And so this time array is simply the array that we're receiving in this function. So it's this parameter. And now, as I said, as we loop over the array, we will keep adding the current value to the sum. So what I mean is sum will be equal the current value of sum plus the array that we received as an input at the current position. And that's it. We're just missing here the increment of the counter, but that's easy to fix. And this one here could be even more condensed. So let me just copy this one and comment out the original one, because remember that we have a more shorthand operator in JavaScript, which we can use when we want to update a value. So instead of sum equals sum plus, remember we can write sum plus equal array I. So this one is exactly the same as this. So if you prefer, you can write just this version, but this here is going to do exactly the same thing. Okay, and just to see if this works, let's actually test this now by logging only the sum. So console.log sum, and now again to test it, I will just call the function calcAverage with simply an array of sum values. So 2 plus 3 plus 6. And we know that this will be 11, right? And so now we can test this function here just to see if this first part that we just wrote works. Let's see. And yes, we get 11. And so this logic here is correct. So we got this array here into the function. Okay, and so R is now 2, 3, 6. And so that's the array that we're then looping over. Okay, so we end up with a sum. And now what we want to return is simply the sum divided by the number of elements in the array, which remember is r.length. And that's it. We can now get rid of this, but now we need to log the result to the console if we want to see it, because this function here now does not log it, it simply returns it. And remember that that is a big difference. So we know that the sum of this is 11, and 11 divided by 3 is something like close to 4. So we could change this here to 7, then the sum would be 12, and 12 divided by 3 is 4. And so then we can make sure that this function works. So it is 4, so great. This means that the function now works. And so now we can use this function to actually calculate the average total. And so here we simply use the totals value that we already created before. And that's it. So the average total value of all our builds plus tips is 275 and 19. And let's actually do the same with the tips themselves, just to get an idea of the kind of tips that were paid here. So the average tip is 42.89. Hopefully that part here was not too confusing. But if you go slowly through the code step by step, you will understand it. All right, and with this, we finished the complete JavaScript fundamentals. So we made a ton of progress here. So congratulations for making it this far. Great job, really. However, as you know, we are really just getting started here. There is so much more to learn. And actually in the next section, we will quickly configure our VS Code editor a little bit better and also set up a better development environment. So that's going to be super useful for writing code a little bit faster. And I will also teach you some developer skills that every developer should really have. But as always, before moving on, make 100% sure that you understood all these fundamentals from this section and the previous section. So if you want, you can redo the challenges, or you can come up with your own small problems or ideas to solve. And by doing that, you will reinforce all these tools even better and ultimately become a better developer faster. Then, when you're really ready, let's together move forward.